Hello, everyone. Hello, BSidesCharm. Thank you for coming out to our talk, Active Directory and the Domain Name System. I am Jake.
And I'm Jim.
We are calling this the wrong direction. Cool. A match made in heaven. But anybody that's worked in Active Directory knows that's not quite true. A match made in hell?
A little too spicy, Jake.
A match made in heck. Very appropriate for our Midwestern sensibilities. I'm from Ohio. He's from Minnesota. So, yeah, we're not allowed to swear. So, who are we?
Well, I'm Jim Sykora. I'm a longtime IT generalist. I'm on the security consultant on identity security. I've joined Trimarc about a year ago. And I'm not famous on Twitter, but that's where you're probably more likely to find me if you want to chat afterwards.
And my name is Jake Hildreth. I'm also a longtime IT generalist. Started programming in BASIC on the Commodore 64, so yes, I'm old. Yeah. Currently run our Active Directory security assessment team at Trimarc. Also, I've been told that I'm supposed to say that I am the co-host of the Twitch happy hour from Trimarc. Co-host. Did I say co-host? Maintainer of the Locksmith AD CS remediation tool that was presented here last year for the first time. And then I'm on Mastodon, so come find me there for shit posting. So what are we going to talk about today? We're going to talk about AD and DNS. So, who is AD? Wait, we skipped ahead too far, didn't we?
Nope.
Okay. All right. AD is what we call Active Directory. We don't actually use that name. It's just cute. Active Directory is the directory service that underlies 95% of corporate networks out there. It combines Kerberos with an LDAP database, and provide some other services like Federation and the previously mentioned ADCS, Active Directory Certificate Services, that anybody that's running an Active Directory environment out there, I bet you're vulnerable to. Just saying. DNS is the domain name system. DNS was born in the early 80s. DNS helps you translate human understandable names into computer understandable IP addresses. It's essential to the modern internet, and you've found that out if you've ever worked in operations because it's always DNS. So for a little quick history on how this marriage happened, before Active Directory was released, in the olden days, we had NT directory services. To do name resolution at that time, you're using NetBIOS, you're using LLMNR, you're using WINS, these terrible protocols with no security built into them. And that's really, even if that directory service was using TCP/IP, a lot of networks back then are using IPX, SPX. Anybody use that? Familiar? No? Okay, good. Oh, we got one. All right, good deal. But then in early 2000, Active Directory was released. It, as mentioned, directory services, including DNS, and they've been pretty interlinked ever since. I mean, Active Directory uses DNS to identify so many things, and DNS stores all of its information in Active Directory. So they're pretty codependent at this point. If you compromise AD, you're going to compromise the DNS. If you compromise the DNS, you could probably compromise AD. So for a little more detail on where this is an out-of-date. We're missing a bunch of slides. All right.
That's okay.
For more detail.
But I can talk about it anyway. So all of the, historically DNS zones and records were stored in a zone file with a start of authority and all the records after that, whether that's bind or whatever. And Active Directory integrated DNS can do that as well with local files. But, doing zone transfers and all that stuff kind of sucks. But, Active Directory introduced multimodal replication or multi-master replication and allows that to work with DNS as well through the integrated DNS zones. That lets all of the DNS zones replicate across your domain, forest, whatever, and all of the records that are in them, and gives you a lot simpler, if not just a completely different way of handling all that replication of those DNS nodes across your network. The other part of that is that all the records for Active Directory integrated DNS zones are stored in what's called DNS nodes. So they're stored in Active Directory, and every DNS node is a record or has multiple records associated with it. So just imagine the screenshots that would have been in the slide if we would have put that there.
What would happen here?
Yep. So I'm going to start out. Oh, there's another slide that's missing. That's interesting. So this is what happens when you edit slides 15 minutes before your presentation, just in case you're wondering. Anyway, so, obviously we've chosen a marriage theme for our presentation, which is really weird because we're weird. But the reason that we did that is because we kind of got on this idea of the traditional wedding blessing of something old, something new, something borrowed, and something blue. So we're going to go through Active Directory integrated DNS in that theme, and I'm going to start out with some old things, including previous research. So going back to how DNS records and zones are stored in Active Directory, which I just briefed on, they're all Active Directory objects, and there's been ways to manipulate DNS records inside of networks and for attackers to do manipulation of name resolution through things like poisoning for a long time. Jake mentioned some things like LLMNAR or NetBIOS name services. Responder came out in 2012. Anybody familiar with Responder? Yeah. So, and there's probably people were doing DNS poisoning maybe before Responder, but that's when it really hit the market. Responder really only works within your local network, and I forgot some words right there, but that's cool. But the thing of it is that DNS records, when it comes to name resolution from a Windows client, you have host file, DNS records, and then below that, in the pecking order, all of your multi resolution where they're doing broadcast resolution. So a while ago, a person named Kevin Robertson did a bunch of research into Active Directory integrated DNS and started off with abusing dynamic DNS updates. Dynamic DNS updates are what let your computers, Windows computers, other computers, create a DNS record in Active Directory integrated DNS and then update their own record as they change IP addresses and change functions. So Kevin was able to abuse dynamic DNS records, and he could create DNS records with that, but he couldn't create a wildcard record. Now, a wildcard record in DNS will let you do much the same thing that Responder does by advertising. Anytime somebody makes a name query for something that doesn't exist, Responder will say, that's me, send your authentication to me. Well, a wildcard record will do that same thing in a little bit different way, in a higher priority, and across any broadcast domain. So, he couldn't create wildcard records with it, but he did a little bit more research, and, Active Directory integrated DNS is just Active Directory objects, and you can create, manipulate, and read Active Directory objects with LDAP, because LDAP is a fundamental part of Active Directory. So Kevin found that a little bit of reverse engineering, you could create DNS nodes for any object that didn't already exist, including wildcard records with LDAP. And Kevin created a tool called PowerMad, which uses LDAP and still the dynamic DNS updates to manipulate and abuse DNS records and also manipulate and abuse computer objects. I wasn't really quite done with that one yet, but that's cool. So DNS poisoning can do a lot of weird things, can redirect traffic to an attacker machine, just like Responder. DNS poisoning can create single name UNC paths, which is interesting in a Windows network because a single name UNC path will end up being in your intranet zone, which for a computer running web client is going to have some different controls around it than a fully qualified DNS record.
Right, much more trusted in the network.
Yep. So all of this works because AD and DNS are joined at the hip, but most importantly, it works because by default, any authenticated user in Active Directory can create those DNS roads. And we're missing a screenshot there. That's awesome. I don't know what happens when you do last-minute slide updates, but we do know now. So imagine that there was a screenshot of from ldp.exe of a DNS zone showing that authenticated records or authenticated users can create any child node. So it's all prior knowledge that any authenticated user can create any DNS node that doesn't already exist. They can't just edit any of them with some exceptions. But while digging into the Active Directory schema and some of the protocol specs, we noticed that authenticated users can create some other things in DNS in Active Directory that were introduced with Server 2016. And they're not really broadly used or really all that well known from what I've seen, but there's a thing called DNS zone scope containers and zone scopes that you can create underneath a zone for the purposes of using DNS policies to create split-brain DNS scenarios and control other types of policies. So what I found is that any authenticated user could create a zone scope container under which any authenticated user could create a zone scope, under which any authenticated user can create a zone or a DNS node. And this is on any DNS server, Active Directory integrated, that's Server 2016 or newer. So we took a PowerMad function and modified it and created a new AD integrated DNS zone scope command. And on the next slide, we got a before up here. So on the left-hand side, you'll see what DNS Manager shows about a test DNS zone, and then you'll see the same thing in ADSI edit. After running new ADSI zone scope, you'll see that the DNS Manager looks exactly the same, but now in ADSI edit, we have the zone scope container, and a malicious zone scope. So unfortunately, that appeared to be a little bit of a dead end for what authenticated users could do with that. The DNS zone scopes were, as I said, created to work in conjunction with the DNS policies from Server 2016 and newer. And those DNS policies are stored on each individual DNS server, whereas that's replicated depending on the scope of the zone. The policies themselves are not replicated. They are per DNS server. And in this case, the DNS servers are domain controllers. So they're stored in the registry in a place where really only administrators in the domain have access to them. But there's some things maybe we could do with it a little bit later on, and some environmental specific things that might allow an attacker that's low privileged to create them. Let's go. So next thing I want to skip on to is some other prior research from Turkyan Malema and Elad Shamir around DACL abuse and tying into Kerberos. So some of the research from these two shows possibilities for relaying Kerberos unconstrained delegation and also abusing resource-based constrained delegation in Active Directory. So this ties back to some of the research that Kevin did in Active Directory with DNS and the PowerMad tool, and some tricky DACL issues that exist on a lot of computer objects by default, especially the additional DNS host name and allowed to act on behalf of other identity, which is the resource-based constrained delegation mechanism for allowing access, and SPNs as well. So this research shows ways that Active Directory integrated DNS and Kerberos interact and can be abused. So when combined with vulnerable DACLs, so a DACL is a discretionary access control list. So that's the permissions on an object, the whole picture of the permissions on a DNS object stored in Active Directory. This can open up some attack avenues that many defenders aren't really even thinking about yet, and I hadn't been thinking about them before starting this talk. Different types of DNS zones have different types of DACLs. And different DNS nodes get different permissions depending on where, how, and who creates them. If a DNS node, which is a record, is created in a certain way, any authenticated user can change it because they'll have generic right on that record, for example. And we're going to have some resource slides and links at the very end of all this stuff. So, assuming those didn't get deleted as well. So there's basically 4 ways to store a DNS zone. There could be a forest, domain, legacy, and files. We're going to skip the files. That's the old way with zone files. It doesn't really integrate with AD. But the screenshot on the left shows a forest zone, and it shows what it looks like in ADSI edit. So it's in its own partition, in its own container, and on the right-hand side, we've got the DACL of that forest DNS zone. So forest DNS zones are stored in that particular forest DNS zones partition, and they're replicated to every domain controller in the Active Directory forest. And in Active Directory, the forest is the security boundary. They have the strictest DACL out of any of the DNS zones, and they don't even allow like a DNS admin any access, special access to it. The most common forest replicated zone is going to be the MSDCS subdomain, which was introduced in Server 2003. It's always going to be a forest DNS zone by default, even if you have a single domain forest. In modern AD, this zone replicates to everything in the forest, and that is how clients and domain controllers locate other domain controllers, LDAP endpoints, Kerberos, KDCs, etc. So, and yes, even in my lab, the DNS is broken. Domain DNS zones are probably going to be the most common type of Active Directory integrated DNS zone. They're also stored in their own separate partition, which is the domain DNS zones, and they replicate with all DCs in the domain, not the forest. The DACL is still pretty strict, but we'll see over on the right-hand side that domain admins gets full control, whereas they didn't on the forest. And DNS admins gets a special DACL on here, which is almost full control, but not quite. Next slide. And then the last thing here, which is really probably pretty hard to see from here, is the main DNS head object for all of Active Directory integrated DNS is stored under the main forest's standard naming convention under system, and then Microsoft DNS. And that Microsoft DNS in system is what I call like the DNS head object, because that controls all of the Active Directory integrated DNS hosts and the permissions that they have. It inherits its permissions from domain root, and permissions at domain root are sometimes pretty atrocious. And then also, you'll see under here that legacy zones are stored in this head unit, and the root DNS servers are stored in that same container, also inherit their permissions from domain root. And here, yeah, just kind of showing the inheritance and how that skips down, and looking at what it looks like in DNS Manager. Next from the something old is abusing DNS admins. Back in 2017, Shea Bear came out with released some research on a DLL's loading issue. So you could use DNS command to replace DLLs on a DNS server. Again, that DNS server is probably a domain controller. So this was released in 2017, and Microsoft patched it with CVE 2021-40469. So this was publicly known and available in the wild to exploit DNS servers and domain controllers to go from a DNS admin to full system or full domain compromise from May 2017 through November 2021. It's been patched now, so any current OS is going to have this patched, but DNS admins is still a lot more powerful than a lot of people expect, and it's not protected by admin SD holder. So on the left, we see what DNS admins group looks like. It has explicit access controls entries. Account operators has full control over it. Inheritance from the domain root. And again, a lot of places have very poor permissions models on their domain root, unfortunately. On the right is what admin SD holder looks like by default in this lab. And this is the DACL that would get stamped on any protected object in AD, like a member of domain admins or something like that. It's a more strict DACL. Inheritance is disabled, so it's not getting any permissions from the root, whereas on the left-hand side, DNS admins it is. So this means that there's a lot of paths from a standard user in a lot of environments that I've seen from a standard user or a low privilege like help desk user to DNS admins, whether that's at the domain root through account operators or just weird permissions on the user containers. Yeah, and DNS admins also has an explicit access control on that DNS head object and for domain DNS zones and legacy DNS zones. They don't have full control, but they do have modify permissions and modify owner, as we can see up here. A DNS admin could grant permissions to any arbitrary service security principal and cause that to inherit down to the legacy zones or root hints. And also, if you are or can become the owner of an object in Active Directory, this by default is even more powerful than having full control / generic all. And if you watch the Trimarc Content Hub in the next couple of weeks, we'll have more on that. And then now for something completely different. I'll be talking about something newer things that I happened upon while exploring AD and DNS. And I'm sorry I'm not used to talking into a mic, so I'm messing that up a little bit, but we'll keep working on it. Defenders sometimes utilize things called DNS sinkholes to prevent access to malicious or unwanted domains. But what if an attacker could sinkhole traffic that might get them caught? Something that we came up with called evil sinkhole. There will not be a domain name bot for this.
I don't know about that. I might buy evilsinkhole.com today.
Yep. So, yeah. DNS admins can, slide please. So DNS admins can create new DNS, domain DNS zones and legacy zones and local zones. DNS zones for an external domain that's in the internal DNS zone will mirror the concept of split-brain DNS. And split-brain DNS allows the internal DNS server to look up external queries and provide an answer for that without recursing to an external DNS server. So this local DNS server thinks it's authoritative and it won't recurse. So it's gonna return the IP address that the DNS admin created, which is 192.168.1.1, instead of whatever the actual real external IP address for applicationinsights.cloudsim.com would be. And you'll notice that, DNS admin, which is a DNS admin, of course, because why not keep up the bit, is the owner on the object and has full control over the object. So DNS admins can also create conditional forwarders. These are also replicated throughout the domain, and conditional forwarders give you a little bit more control over what's going on, but it'll forward any query for that entire DNS namespace to explicitly defined DNS servers for lookup. And those explicitly defined DNS servers could be an attacker-controlled DNS server, an attacker-controlled DNS box, or just nothing, because if the query doesn't forward, it just times out. And that's what we see. That's what would have been on that slide. So what could you use evil sinkholes for? Well, you could. I've seen some EDRs that you could actually blind with DNS. Thankfully, most of them have figured this out and understand that, hey, it's always DNS, and put some fail-safe IPs in there. But you can kind of mess with the telemetry of some EDRs. You can mess with SIMs, whether they're hosted internally or in the cloud. You can update hosts and mess with like patching and AV signatures, AV uploads. redirect traffic to trusted sites or internet zones, but it's really loud. You can see it in the GUI. It applies to everything in that entire namespace. So I'm just wondering if there was a quieter way. And I looked at some of the stuff in Server 2016, which was those DNS policies that got introduced. They're a little bit more interesting because they don't show up in the GUI. The primary interface is through PowerShell. The fun thing about this is it's really a post-compromise scenario because these DNS policies can only be created by an administrator on each individual DNS server. That's because the DNS policies are stored in the registry on the DNS server, aka domain controller. They're stored in HKey local machine software, Microsoft Windows, blah, blah, blah. And only administrators and system/trusted installer have access to that registry key by default. An attacker with administrative rights, aka post-compromise, could perform some really targeted DNS manipulation to block or redirect traffic. And you could do that in concert with those domains, those DNS zone scope containers and DNS zone scopes. Because the query policies in here allow you to define subnets that you want to manipulate the queries to come from. So you could create that subnet down to a /32 and just use one host that you want to mess with the traffic on, and let you either filter queries out or replace those queries with the things that you put in the zone scope. So, if an attacker could get, a system or trusted installer on the DNS server, they can manipulate that DNS record also, but it's a domain controller, so again, post-compromise. But if the AD environment is poorly configured enough, which
we see all the time.
There's sometimes overly permissive DACLs at the domain root, or like weird permission issues on group policy objects that are applied to the domain root or to the domain controller's OU. That might allow somebody to execute code on the DC as system or make registry modifications that would allow you to manually create these same DNS policies across all domain controllers. But again, that would be post-compromise. Just remember, these DNS policies in Server 2016 Plus are not just for malicious traffic. This is really the Microsoft recommended way now to implement split-brain DNS if you actually need to do that. It's also great for filtering out malicious queries, malicious sites, and if you don't have like a forwarder or something to do that for you. And this is what we originally called Jim's big new hair-brained idea, dangling SPNs. So I want to ask you, how many of you ever have configured an SPN on an object in Active Directory? Raise your hands if you got two. How many of you have deleted an SPN off of an object in Active Directory? Okay, good. All right, cleaning up somebody else's mess. That's great. So this is more of a thought experiment or a theory than a working concept for now. But and while I think I know Kerberos, every day I'm reminded by Kerberos how much I don't know. So where Active Directory integrated DNS relies on Active Directory to function, many parts of Active Directory rely on DNS to function. That includes Kerberos. More specifically, Kerberos relies on user principal names, service principal names, and especially that host part of the SPN, all rely on DNS. So there's a couple of blog posts out there that inspired this idea. There's one from Charlie Clark, another one from Dirk-Jan, Kevin Robertson, and then also Elad Shamir. Slide. Which isn't there now. Cool. All right. So those blog posts cover some ways of manipulating an existing computer object to add an SPN to it, then create a host name and a DNS record for it to manipulate it for relaying Kerberos unconstrained delegation or manipulating it to get resource-based constrained delegation to work. But I've noticed a lot of times looking at Active Directory environments, especially in really large organizations, that SPNs get created and added to service accounts, but they rarely get taken away. Nobody wants to break anything. So if there's an SPN out there that points to a host that no longer exists, can we take that SPN and that host name and manipulate DNS to redirect that Kerberos traffic and get it to go to an attacker-controlled machine or to a higher value target? And that would depend on whether it's unconstrained delegation or constrained delegation. And now that I've kind of went through something old and something new to celebrate AD and DNS's 23rd anniversary celebration, you might be thinking about or wondering, like, maybe I should just ditch Active Directory integrated DNS, or maybe you already did. Outsource all your DNS functions to a third party, like Bind or maybe some hosted DNS solution. There's a bunch of now cloud DDI solutions out there. I just want you to think about, as critical as Active Directory is to DNS, DNS is critical to Active Directory in that control plane for Active Directory. And if you outsource that DNS to that provides all your records for Tier 0 DCs, for Kerberos, for LDAP, and everything to a third party, you're giving a part of your control over Active Directory to that third party, or maybe even your network engineers. So instead of thinking about that, let's have Jake tell us about something borrowed.
Yeah, so we're calling this something borrowed because all of these already exist. This is not new knowledge by any means. So, ways to defend your DNS environment. Number one, not really DNS related, sorry, but it still needs to be included. Disable LLMNR, disable NBNS, and maybe disable multicast DNS. The first two are not required in a modern network. Haven't been for a while. Get rid of them. The third one might be, but you probably can get rid of it too. Next up here, we've got a wildcard record. As Jim mentioned, PowerMad can create a wildcard record if it does not exist. However, it can't create a wildcard record if it does exist. So be proactive, get out there, create your wildcard record. It's a little touchy on exactly what you need to do. If you are in a single domain, oh, I need to read my notes here. If you are in a single domain forest, you should create a wildcard record that is an A record. If you are in a forest with multiple domains, in a DNS suffix search order, with DNS suffix search order set up, you need to create that as a text record, or else non-fully qualified domain name queries are not going to work. That being said, just use fully qualified domain names anyway. And then we also have the WPAD record. As we talked about earlier, we mentioned it. We didn't really talk about it. It's the web proxy auto discovery record. This kind of tells your clients where there's a proxy in your network. You might need it. You might not in your environment. If you do, make sure it's set to the correct address. If you don't, create a TXT record. Any requests for that WPAD record are just going to fail. Empty out your DNS admins. I think we've shown how easy DNS admins can be to attack, and the excess rights that DNS admins tends to carry in most environments. Yeah, just keep it empty. Let your AD admins do their thing. Second to last here, eliminate legacy zones. A legacy zone, when you're creating a DNS zone, and it's got that option that says, Windows 2000 compatible, don't choose that one. Get rid of those. Windows 2000 has been end of life for over a decade. Please clean up your shit. And then the last one is just taking a look at your global query block list. This is a list that lives on each DNS server that says, these are host names that I am not going to resolve. They're, by default, the WPAD record and ISATAP are included. There were well-known attacks for a while on those. There are ways to bypass the global query list, but just make sure those two, at the minimum, are included. And then it's time to dig into everybody's favorite thing, auditing. Number one here is not exactly auditing. It's actually configuration, but DNS, as it exists currently, allows you to set up a service account to do dynamic updates on DNS nodes. So what this is, instead of Jim's computer saying, I want to create a DNS node called Jim, and now Jim's computer owns that Jim record, now Jim says, I need a DNS node called Jim. The service account creates that record, has ownership, has full control over that record. What this gives you then is you are able to lock down those zones quite a bit tighter and remove authenticated users from having the rights to create DNS nodes. That makes that second point there, auditing your DNS DACLs, a lot easier. As Jim showed, there's a lot of interconnected stuff when you get into DNS. If you can minimize the amount of possibilities of what will work, your auditing becomes a lot easier. Third there, audit DNS zones. These are available in your DNS console. You should be able to look through them and say, hey, maybe hacker.io shouldn't be a zone that we have. Maybe it is for you, I don't know. Same thing with zone scopes. Do they make sense in your environment? Same thing with policies. Do they make sense in your environment? Now, I mentioned that, DNS zones, you can see those in the DNS console. Zone scopes, you cannot see in the DNS console. You're going to have to take a look using PowerShell or ADSA edit or IPAM to see these zone scopes. So be aware of that. And then the policies, because those are stored on each DNS/DC server, those need to be queried individually. They're stored in the registry. That makes it difficult. So use PowerShell to look at those. And then for dangling SPNs, if you hate yourself, you could probably find these all in Active Directory users and computers or ADSI edit, but I don't wish digging into every single object in your environment through the GUI on anyone, even Jim. So instead, PowerShell, use that, enumerate those and find out those hosts that no longer exist. So it's all well and good. It sounds like a lot of stuff, but we got something blue for you. It is the blue tuxedo. So Jim often wore a blue tuxedo in high school.
Back in high school.
We were really looking for a picture of him in his blue tuxedo back in the day. Blue Tuxedo will be released later this year. Hopefully at Wild West Hackin' Fest in their tool shed, because that perfect place to release tools. But we're going to go through, we're going to search for those dangling SPNs that we talked about. So again, that's an SPN where the host name, host portion no longer exists.
Which, even if you can abuse those with DNS, you should still clean that up.
Yeah, that's right. Again, clean your shit up. We're going to check DNS admin's membership. So again, we're going to try and get that as close to 0 as possible. If it can't be gotten to 0 for whatever reason, we're going to check and make sure that at least those users are in other groups that are protected by the admin SD holder object. So that would, minimize the amount of abuse that they could take. Then we'll scan for both the wildcard and WPAD records. And then, depending on exactly what's found, offer some different suggestions. So if it's a TXT record, in most environments for both of those, it's going to be good to go. If it's an A record, a little suspicious, depending on, again, your exact environment. If you find an NS record set up for wildcard, straight to jail. Like, it is time to figure out what's going on in your environment. And then if you have none of those, if they don't exist, the Blue Tuxedo will offer to create them for you. So, again, proactively taking care of your environment. We'll dig into the global query block list. Make sure that those two settings, WPAD and ISATAP, they both exist, and then list the other ones too, because as we talked about earlier today while editing these slides poorly, we've realized that DNS admins may be able to create a different sinkhole using the global query block list. So,
yeah, DNS admins can enable, disable, and modify the global query block list. So, and that's a per DNS server setting. It is not synced by
correct.
Active Directory.
Correct. And then we will check to make sure that you've got a DHCP dynamic update service account set. If that doesn't exist, we'll let you know. If it does exist, we'll let you know if the password is old, because in the environments that we assess, 90% of the service accounts never have password changes, or they're over 3 years old, and yeah, just terrible. Another thing related to that, the DACLs, we are going to look and make sure that the DACLs on your various DNS items make sense. Authenticated users should not have write permissions to your DNS head object, for example. Additionally, we're still working this out, but it seems like some of these DNS attack tools like PowerMad kind of have a signature to when they modify DACLs. So take a look at that. If we see that, we can indicate, hey, this looks like PowerMad created this. And then one thing that we had on the slide, didn't really mention, was tombstone DNS records. When a DNS record becomes tombstoned, it becomes world writable. Also bad. Conditional forwarder auditing, we're going to list those for you. Make sure that the conditional forwarders make sense in your environment yet again. Is google.com going to a Russian IP? You might want to delete that one. I don't know. Maybe. Zone and zone scope auditing, same thing. Do you know what they are? If you don't, you probably don't need to have these set up in your environment. And then two things that we did not touch on at all in this talk, but are important, are your forwarders. When you deploy DNS server out of the box, no forwarders are configured. And instead, all of your queries are going to the DNS root servers. It's slow, it's inefficient, it's possibly insecure, and it's an iterative process. I mean, it starts at the DNS root and then works its way down, whereas a normal forwarding process is recursive. It works its way up, etc. Did you have something you wanted to say there, Jim?
Oh, I was just going to mention and remind everybody that the DNS root hints object exists in a pretty insecure area where all the permissions are inherited down from the domain root.
Right.
So.
And then the last thing on the list here is kind of a part security, part hygiene. When your DNS servers are making requests out to forwarders, they randomize their source ports. By default, it's 2,500 ports. That's good. You can go up to a maximum of 10,000. We're just going to tell you to do that. And we have not seen any impact on performance, so why not do the maximum? So hopefully, with a blue tuxedo in any wedding is going to make sure that that wedding lives happily ever after. So, thank you all for coming out. You didn't have to come out. We love that you're here. I want to thank Kevin Robertson, Shea Bear, Charlie Clark, Dirk-Jan Malema, Elad Shamir, BSidesCharm for having us, Trimarc for paying for us to be here, Jim for his first presentation.
Thanks, Jake.
So if you have any questions, I saw that we've got less than 5 minutes left. We can do some questions. Anybody? Yeah, what you got? Oh boy.
We were mostly looking at Active Directory integrated DNS, not Azure Active Directory integrated DNS for this specific talk. But it's a whole nother ball game. Yeah, there's a lot of stuff there too, and I haven't even dug into it myself.
Yeah, we have not even touched that yet.
Oh, from that aspect, absolutely. We see a lot of stuff from, so we look at Azure AD. We haven't looked at Azure DNS. Be very clear about that. Thanks, Danny. So yeah, see a lot of stuff with Active Directory on-prem and Azure AD where people are syncing privileged roles from on-prem AD up into Azure AD and having those as be global administrators and stuff like that. So that opens up opportunities where somebody can get control of on-prem AD. They can most likely compromise your Azure Active Directory tenant as well. Yeah, there's a lot of attack paths with that. And I think Christina just
Yeah,
put out a blog on some of the low-hanging fruit for that.
Christina Murillo will be releasing. Is it later this week, Danny?
Yes.
Later this week. What's that? Next weekend. Hub.trimarcsecurity.com. Man, having a marketing guy in your front row, it's terrible.
Sorry. Yeah, so I guess we have the reference slides at the end of this, assuming that we didn't delete all those, but I just wanted to
they're
remind
gone.
you.
I promise you they exist.
So we'll fix that, and we'll put some slides that actually have all the stuff we were talking about on the internet later. But I just want to remind everybody, you know, that there's one thing that's really true in Active Directory. I just want to say, you know, I'm Jim, this is Jake, but it's not DNS. There's no way it's DNS. It was DNS.
Thank you.